Lesson 6, which is describing transformations. There's one simple point in this summary that the authors want to make, which is, if you have a sequence of transformations, for example, in this case, a translation and then a reflection, if you switch the order, if you do the reflection first and then the translation, you will end up in a different place. So the order does make a difference when you have a sequence of transformations. If the transformations are different, if it's a translation and a reflection, if they're the same, if you're doing a translation, then another translation, or a rotation and another rotation, or a reflection and another reflection, then the order does not make a difference, and I'll show you that in just a moment. So this is the first example, and in this example, there is a translation. So it's going to be translated up 2 units, 1 unit, 2 units. So it gets translated up to here, and then this triangle gets reflected over the x-axis and ends up down here. And so notice that this point A moves up here 2 units, so then when it gets reflected, it goes way down here, so it gets reflected much farther away from the x-axis than where it started. And this point here doesn't have a label, it's called point B. This point even gets reflected farther over the x-axis. So translation first, then reflection. Well, what if you turned around and did the reflection first? So go back to here and took this triangle and reflected it first down to here and then translated it up. What's going to happen? Oh, there the triangle's reflected. So this blue triangle got reflected to this green triangle. All right. So what if we do the reflection first? So in this case, the reflection is going to move the triangle down here, and then it's going to be translated up 2 units. And now notice that it ends up overlapping the original triangle. That's because it's reflected first, so it's still pretty close to the x-axis. And then it gets moved up and actually crosses this x-axis and overlaps the original triangle. So let's see what that looks like. Here's the reflection. And so now this is going to be translated up. It's translated up to there, and now that triangle is right here. So let's look at these side by side. So this is the first one, reflection, then a translation. Notice that the starting triangle is the same in both cases. So then here's a reflection and then a translation. So it gets reflected down here, and then it gets translated up 2 units. This one gets translated first. So the triangle starts here, gets translated up here, and then gets reflected way down here. Now the reason that the order makes a difference is because the line of reflection is staying the same. It's not changing. So naturally, if you move that triangle to a different place, then it's going to end up in a different place when you reflect it. Or if you reflect it first and then move it. So it will end up in a different place. So what if there's a translation followed by a translation? So we're going to translate this red point, and we're going to end up over here at 4. Actually, this is 1, 2, 3, 4, 5, 6, 7 at 7, -1. If we count this as the origin. Okay, it starts at -3, 2. I'm going to translate this 6 units to the right and 2 units up. So that's the first translation. So it's going from this point to this point. And then we're going to translate it 4 more units to the right and 5 units down. And so it's going to end up at this point, like I said, 7, -1. Now, what if you switched them and did the 4 units to the right first, 5 units down, that's what this is, and then did the second translation, 6 and 2 units. So 6 units to the right and 2 units up. Notice that you end up in the same spot, the same point. So the order does not make a difference if you have a translation followed by another translation. Doesn't matter. How about reflection? Well, if you take this pink point and you reflect it over the y-axis to this point here, and then reflect it over the x-axis, you end up where this blue point is. On the other hand, if you take this pink point and reflect it over the x-axis first down to this red point here, and then over the y-axis, you still end up at this blue point. So whichever reflection you do first, it doesn't matter. So reflect over the y-axis and then the x-axis, you end up here, or reflect over the x-axis and then the y-axis, and you end up here. So the order does not matter if it's a reflection followed by a reflection. And finally, this looks like it's a little bit tough to look at, but if you have a rotation followed by another rotation, it doesn't matter either. So this is the start point right here. This is point A. This is where we're going to start. And we're going to rotate point A 90 degrees counterclockwise, and it's going to go to point B. So you rotate 90 degrees counterclockwise, and you end up at point B. And then we're going to rotate point B 180 degrees clockwise. So we're going to go 180 degrees this way and end up way down here where point C is. And notice that the center of rotation is R, so you have to use the same center of rotation. So now let's do it the opposite way. We're going to start at A, and we're going to rotate 180 degrees clockwise first to D. So 180 degrees clockwise, first to D, and you end up here. And then we're going to rotate 90 degrees counterclockwise. We're going to end up at that same point, C. So again, if you have two rotations in a row, the order does not matter. You have to use the same center of rotation, and that does not change. All right, so let me show you what happens for a rotation. We looked at what happens if you have a translation, reflection, then reflection, translation. We talked about why that image changes spots. But let's look at a rotation and a translation. So this is going to be the center of rotation right here, -3, 2. And this, we're going to start at this point here. This is 2, -3. So in the first case, let's rotate 2, -3 up here 90 degrees. So the point ends up here. So this is rotation number 1. The point ends up here. And then we're going to translate this 6 units to the right. 1, 2, 3, 4, 5, 6. So translation number 1. Now, on the other hand, what if we did the translation first to here, and then you have to use the same center of rotation, and that's the key. That's why this point will not end up in the same place, because we're translating to a different spot, but we're still going to use the same center of rotation. All right, this is a rotation, then a translation. All right, so what if we translate? So translate 6 units to the right, so this is translation number 2. And now we're going to rotate. This is the center of rotation. It's going to go 90 degrees. So it's going to end up way up here. So you imagine drawing a 90-degree angle from here and out this way somewhere. We could count and figure that out exactly. And it's going to end up here. And there it is right there. So now you rotate 90 degrees, and it ends up way up here. So this is rotation number 2. And you could convince yourself that is correct by counting. So you count down and over, and then you rotate 90 degrees and count over and up, and you're going to end up in the same spot. But notice the point is that they end up at different places. So the order does make a difference. If you translate first and rotate second, you end up here. If you rotate first and translate second, you end up here. So the order does make a difference if you're mixing a translation with a rotation, but it does not make a difference if you're doing translation, rotation, or reflection. What I have not looked at is what if you have a reflection and a rotation, and I imagine that order will make a difference because you're moving images, but you're keeping the same line of reflection or the same center of rotation. So I imagine that will make a difference. And that would be a fun thing to look at. Have students do a rotation, then a reflection, and then reverse them and see where you end up.